welcome all you grade 11 mindsetters. It is a Tuesday. Physical sciences is right here. 5 o'clock is the time. I am Looney, and with me in studio today is Tracy. Tracy, how are you?
I'm well, thanks, Looney. Good to have you, grade 11s. Welcome. It's good to be here and good to be doing some mole calculations. So we're looking forward to it.
Mole calculations.
Oh, mole calculations, and it's all these chemical calculations which can get confusing. So grade 11s, I'm hoping you've got a pen and paper with you and that it's going to be a great show.
All right. Grade 11s, you heard it. Have a pen and paper to write down all your calculations there, just. Okay. On Facebook, to keep in touch with us, you can go on facebook.com/learnextra. Our handle on Twitter is @learnextra. So make sure you tweet me because it's been very quiet. Tweet me, ask me any questions that you may have about the show. I'll ask Tracy as we go along during the show. To download all the videos, the show notes, and the schedules, past papers, exam papers, and all of that to get you prepared for the upcoming exams, guys, go to learnextra.co.za/live. And before I hand over to Tracy, I'd just like to send a shout out to my family. My sister is feeling very sick today, so I hope you get better soon. And I love you very much. And to my nephew and my niece, you two little naughty rascals, I love you too. So Tracy, let's do it.
Thanks so much. Well, grade 11s, mole calculations. There's plenty involved here. So let's get started. What we're going to be looking at today is we will be revising the concept of the mole. Now, you might have looked at the mole in grade 10 last year. So we're going to be revising that. We're going to discuss calculations with gases. So we'll be looking at volume. We're going to be looking at solutions. And solutions would be, we'll look at concentrations of solutions. Okay? And in other reactions. So we'll look at mass, molar mass, and all those types of things. Very important. We'll also consider the information given in a balanced chemical equation. Now, a balanced equation is the fundamental basis for us to be able to do these calculations. So important that we revise those. And then always, we like to solve problems. And these problem solving involving ratios with gases and with solutions will be incredibly important because that's the fundamental part of this. We're looking at calculations and we want real data to come out of that. Let's get straight into the recap of a mole. Now, we have considered the mole as being an amount of matter. In grade 10, you will have learned a mole is an amount of matter. It's the SI unit for matter. And you might have considered Avogadro's number, SI unit, for an amount of matter. We will have looked at maybe Avogadro's number, that's 6.23 times 10 to the power of 23. Very, very, very useful because it's going to give us a quantity that as scientists we can work with. Okay, so let's get straight into what you might have looked at last year with regards to mass. So number of moles, you probably have come across this equation. Let's revisit that quite a bit. So the mass, number of moles is equal to mass over molar mass. And as you have a look at that equation, this M at the top is the mass of the sample that you have. Okay? That would be given in grams, right? This M at the bottom here stands for the molar mass. Okay? And that you would need to go and work out from the periodic table. So we're going to do one in a moment. But what you're going to be doing is taking the relative atomic masses of all of the components of this compound or the substance that you've got and add those together to give the relative molar mass or the molar mass of the substance. And that would be in grams per mole. Okay, that is our unit. And N is standing for, and I've got all these listed here, for the number of moles, and so that would simply be in moles. Let's get into trying one of these. So I'm going to look at, let's pick a substance, potassium nitrate, just because I want you to get used to dealing with maybe some big ones and I'm going to say we've got 75 grams of that in a sample, potassium nitrate. So let's work with it. Well, my question is going to be, how many moles do we have in that 75 grams? Well, my mass is the 75 grams that I gave you. My molar mass I would need to go and work out. So always in brackets, put in here what you've got, what you're working out. And that's going to be equal to, well, potassium's, its molar mass, its relative atomic mass. Now, I've got this periodic table. You would need to go and reference the periodic table that your teacher's given you in a test or whatever. You need to go, maybe it's in the front cover of your textbook. Go and work with the periodic table that you've been given, and you're going to go and look for the approximate relative atomic mass. That's the number on this table. It's given at the bottom. Usually they're also given to 2 decimal places, so use whatever decimal places you have got on your periodic table. So I've got potassium 39, I've got nitrogen 14, and I've got oxygen 16. Let's go and use all of those. Well, that's going to be, we had here 39 plus nitrogen was 14 plus, now oxygen was 16, but remember it was 3 times, okay, because that little 3 there is indicating to me that we have 3 oxygen atoms in this compound, okay, in the substance. And so I would go along to my calculator. Let's just clear all of those. And what was it? 39 plus 14 plus 3 times 16. And we get 101. So I can come across here and write in that the molar mass is 101. What would the unit be? It would be in grams per mole to the power of -1. So we now get to do this calculation. Number of moles is equal to mass over molar mass. Grade 11s, it's incredibly important that you write down the original equation first. That whenever you're doing these, that you write down the original equation and then you substitute. So our mass was 75 and 101 was grams per mole. Let's go across to the calculator. We'll clear those. 75 divided by 101. And we get our answer 0.74. And that would round it off. So 0.74. And we need to have our unit. It would be moles. Now that's just a recap of what we've looked at with mass and molar mass. We need to move on now and consider doing some more things with moles. Because you might say to me, well, I've worked with masses, but it might be really hard to weigh off, get a mass for an amount, a volume of a gas. Okay, because gases, they fill up the space that they've got in the container. So we would need to work with a volume rather than a mass. So have a look at this one. The volume of 1 mole of gas at STP, that would be at standard temperature and pressure, is 22.4 decimeters cubed. What we're saying here is that 1 mole amount of gas would take up 22.4 cubic decimeters of space if it was at standard temperature and standard pressure. Now, you can go and work that out. This number comes out of the ideal gas equation. PV is equal to nRT. And I know you've been looking into that, okay? So if you were to plug in the pressure, 101 kilopascals, 101.3 kilopascals, and the temperature of 273 Kelvin, if you plug those values in with your universal gas constant and N being 1 for 1 mole of gas, you can work out that the volume of gas that 1 mole would take up would get us to 22.4 cubic decimeters. And that is from the ideal gas equation. So all gases should occupy the same space. And we can now turn and work with number of moles is equal to a volume divided by what the volume of 1 mole should be taking up, okay? So, which is the molar volume. So here I've got the volume of my sample again. Remember we had the previous one was the mass of the sample. Now I've got the molar volume. And the N again standing for number of moles. What we can do here is use any number of moles, and we'll do some questions on this in a moment. We can work out any number of moles of gas. Now this equation is specifically when you're dealing with gases, so keep that in mind. Just a few hints here. Converting. I know students often struggle with converting, so I just thought I'd keep this in here. Hint, hint, make sure that you can convert in cubic values. 1 cubic decimeter is 1,000 cubic centimeters, and that's probably the one we'll deal with the most because it's quite a common, quite common units. 1 cubic meter is the same as 1,000 cubic decimeters. And lastly, we need to discuss a balanced chemical equation. Now, a balanced chemical equation is vitally important. As I said at the start, we're going to be dealing with whole reactions, okay? And that balanced chemical equation is going to help show us the ratio of the substances one to another. The numbers in the front, so your balancing numbers, in the chemical, in front of the chemical symbols, describes the mole ratio of the reactants and the products. The reactants forming the products. Those numbers in the front, those balancing numbers are often called coefficients. They are incredibly, incredibly important because we're going to be dealing with mole ratios. Okay? Let's tackle a question or two. I think I've skipped a question. There we are, question 1. What is the volume of 3 moles of nitrogen gas at STP? Now, there are multiple ways you could answer this. You could, if you're very happy with ideal gases, go and throw this into PV is equal to nRT. You've got the temperature and pressure on your data sheet because that's the standard temperature and pressure. But we could also work with this equation that I have just worked with you. We've got the number of moles, we've got the molar volume, and that was 22.4 dm cubed. Okay, more moles per dm cubed. Let's just take that out and write in here moles dot dm to the minus 3. So I have N is equal to V over molar volume, and we have got the number of moles and the molar volume. So let's try and find the volume. What are we going to do? It's dividing that side, so it comes across and multiplying. Vm is equal to V. Number of moles was 3 times by 22.4, and we get to, well, let's just throw that into the calculator. 3 multiplied by 22.4 is equal to 67.2. So I come across here, my answer 67.2 decimeters cubed. Now that is the volume of N2 at a standard temperature and pressure. And grade 11s, I want to really highly recommend to you that what you would do with these is that you would make sure that when you write your final answer to a question, finish it off by saying what we're working with. Okay? The reason I suggest that to you is because we're now going to start to work with long chemical equations, and we might be working out the number of moles of one substance and another substance in the same question. So do that, and it will help guide you in terms of going back and checking that you've got the right substance in terms of answering your question, and you won't confuse yourself. So I think we should head for a break soon. And what we need to do is we're going to come back, we're going to look at concentration, and then we're going to tackle plenty of questions. So thanks. Over
Alright.
to you.
Mindsetters, we are going to take a very short break. Remember, we are still running the After Earth competition, so stay glued onto your TV screens because we're going to play the trailer, and make sure you come back. Don't just go away now after the trailer. Come back and then I'll tell you all the information you need to know in order to enter the competition. So stay tuned, Mindsetters. Welcome back, Mindsetters. I hope you guys very excited about that trailer. Will Smith and Jaden, just doing their thing on After Earth. So all you need to do in order to enter the competition is enter the keyword that I'm going to give you right now on learnextra.co.za/After Earth. So grade 11s, your code word is matter. Matter is your code word. All you need to do, learnextra.co.za/After Earth and enter in matter, and then you can stand a chance to win yourself 2 tickets for yourself and a friend. Remember, if you don't have a friend, guys, I'm always here. Tracy's here if she wants to go watch After Earth. Lots of people here at Mindset, guys, won't mind. Accompanying you, being the plus one. So all you need to do, just go onto the website, guys, enter matter, and remember, the competition does close tonight at 12 p.m. So make sure you enter as many times as you can to stand a chance to win, and tomorrow the winner will be announced on tomorrow's show. We also have an After Earth special tomorrow, guys, from 7 till 7:30. The Life Sciences show will be giving you the whole Life Sciences plan on After Earth. So basically what's happening is that After Earth, the movie, is turned into like life sciences. So we'll be discussing things such as evolution and all of that. And Macmillan will be streaming in live from their digital launch. So just make sure you tune in. It's not just for grade 12s, it's for everyone, grade 10 to 12. Make sure you watch tomorrow, 7 till 7:30. It's going to be very, very exciting. So with all that said, Tracy, I think we should just
Get started.
Yes.
Thank you. So grade 11s, we've just been discussing volume, and the volume of a gas can be used to calculate the number of moles, and we can work with moles. We now want to work about, what about solutions? What about if I mixed stuff in to make a solution? So we're going to be dealing with a concept called concentration. Now, I know that you've thought about concentration before. You know that if you put 1 spoon of sugar in the tea or coffee, it's sweet. But if you put 3 or 4 spoons of sugar in the coffee, it starts becoming very, very sweet. It's highly concentrated with that sugar, okay? And we want to, as scientists, have a specific word for what we mean by concentration. So the concentration of a solution refers to the number of moles of whatever's dissolved, the dissolved substance, per dm cubed of solution. So it is the number of moles in a certain volume of the solvent, okay, whatever the liquid is that we're dissolving. And we come with a nice equation. Concentration is equal to N over V. Now, this concentration is measured in moles per cubic decimeter. The N is standing for moles, number of moles, I should say, and the V is the volume of the liquid that is dissolving it, the solute in, okay? It's the substance, the liquid substance that we are using as our solvent, okay? Now, many students get confused when in a question they get a volume. Be careful. You need to read the question well. If the question is asking you about a volume of a solvent, the liquid, okay, or if the volume is a question about the volume of a gas. So read the question very carefully, because it's going to be specific, different equations for each of those different ones. This is for solutions. Important, very important. Okay, so let's get back tackling into some questions, and hopefully that will help us to visualize where we headed. So we've done question 1 already. I'm going to skip through question 2. That's just another one on volume of gases. So I want us to go across to question 3, because here we're looking at making up solutions, and so I want us to practice that right now. I want us to note that we are looking at making up a solution of sodium hydroxide. Sodium hydroxide's formula NaOH. Okay? 17 grams of that, sorry, we should have the grams there. 17 grams of sodium hydroxide is dissolved in water, and the solution made up to 250 cubic centimeters. That is my volume, all right? This 17 grams is the mass of the sodium hydroxide. And they asked me to calculate the concentration. So let's head down to the bottom where I can have some space, and I'm going to write down those values. We've got concentration is the question. That's what we're trying to find. My mass was for 17 grams of sodium hydroxide. What else did I have? The volume was 250 centimeters cubed. Now, firstly, we have to get into number of moles, because as you'll remember, this is my equation, number of moles over volume. I don't have number of moles. So firstly, we need to take whatever our value is here and go from a mass down to a number of moles, okay? Then from the moles, I can work that into a concentration, okay? So firstly, we've got to go from mass to moles. How do I do that? Well, I've got the mass of my sample, and I need another value. I need the molar mass. So on the side here, I'm writing molar mass of NaOH. Okay, that is the sodium hydroxide. We go across to the periodic table, and we need to go and find those. So sodium, there it is, with, let's change the color, 23. Oxygen, we had it earlier, 16, and hydrogen, 1. Remember I said use the periodic table that you've been given, because you might have decimal places and things like that. This one's been rounded off. So here we're coming back, and we're going to write, what was it? 23 plus, oxygen was 16 plus, hydrogen was 1. And we can work that out. So our calculator, 23 plus 16 plus 1 is giving me a lovely round number of 40 grams in 1 mole. Okay. Now I've used the slash there, or you could write it as 40 grams dot mole to the power of minus 1. So let's take that mass and work it to number of moles. I'm coming across here. Number of moles is equal to mass over molar mass. And I had 17 divided by 40. Okay? And that's going to give me the number of moles of sodium hydroxide that I'm including into this solution. So let's go across to the calculator. And we have 17 divided by 40 grams in 1 mole. And that's 0.425. Let's jot that down. 0.425 moles of NaOH. Okay? The focus here, you might say, but I know it's NaOH. The trouble is that you might have many sub-questions to this big question. And I highly recommend that you just jot that down so that you know what you're working with. You can come back to it and work with it a lot. Okay, so that's the first part of the question. Have we answered the question, though? Check. The question asked us to find the concentration. We haven't done that yet. We now have the number of moles, and we have the volume. So we can go and use our final equation and plug that in. The thought, before we move on though, is my volume in the correct units? Okay, we got told it was 250 cubic centimeters, but concentration is worked out in cubic decimeters. Okay, moles per cubic decimeter. So I first need to go and convert this, and I'm listing it over here. Well, cubic centimeters to cubic decimeters, I must divide by 1,000. So 0.250 decimeters cubed. Okay, because there are 1,000 cubic centimeters in a cubic decimeter, so I need to divide by 1,000 to go from cubic centimeters to cubic decimeters. And so I can work on my final equation. Let's go. Concentration is equal to number of moles over volume. The number of moles, I worked that out, 0.425 moles, and that's divided by the volume. Watch out, we had to convert that volume, and the volume was 0.250 decimeters cubed, and we can get to our final answer divided by 0.250, and we get 1.7 moles per decimeter cubed. Okay. Now, just a thought here. You might have rounded off your answer at this point, and that's absolutely fine. So we could have rounded off to 0.43 to 2 decimal places moles. That's absolutely fine. And if we had done that, going across to my calculator, let's just 0.43 divided by 0.25, and you're going to get a very similar answer. Okay. What was it? 1.72 moles per decimeter cubed. Okay. Very helpful to always write down your answer and work with that. Let's go to the next one. Given the equation, we've got a nice, lovely equation. 20 cubic centimeters of a 1.3 mole per cubic decimeter potassium hydroxide solution. Wow, plenty of information that we get thrown at right in the first sentence. You mustn't get scared by that. What you need to do is start listing the values. And what I find to work very well for me is to actually write out the equation that you get given, okay, and then rewrite in a list directly underneath each substance as you are given the information. So I'm going to start to do that. We have potassium hydroxide, KOH, plus HNO3 forms potassium nitrate plus water. Okay. 20 cubic centimeters of a potassium hydroxide solution. So immediately underneath the potassium hydroxide, I'm going to start with my list. Okay. That initial 20 cubic centimeters was a volume value, okay, because the cubic centimeters tells me that it's a volume. Just as we talk about the cubic centimeters, recognize that that's something we're going to need to convert, okay? We need to work in cubic decimeters. So immediately, I can do that conversion. It would be 20 divided by 1,000. And so we can go with that. 0.0, I think it's 0.02, 1, 2, 3. There we are. 1, 2, 3. That's it. Decimeters cubed is my volume. This one, 1,3 moles per cubic decimeter. That is now a concentration value. Okay, so 1.3 mole per dm cubed. Okay. Then let's keep going. Was pipetted, so allowed to specific volume into a conical flask and titrated with nitric acid. So that's my next substance. Maybe let's change pen color for that, the nitric acid. It was found that 17 centimeters cubed of the nitric acid. So now I'm going to do a little dotted line, and I'm going to be working with this stuff. Obviously, on the board, we're going to be going quite large, but let's go 17 centimeters cubed, and again, that's going to need to be converted. So 0.0 0.17 decimeters cubed. You're of course more than welcome to just convert as you're working through the calculations, but I do find it's helpful at the beginning. It was found that that quantity, 17 cubic centimeters, was needed to neutralize the base. Calculate the concentration. Concentration equals question mark. Now, as you work through these, it's incredibly important that we work with a balanced chemical equation. And what we're going to be doing is we're going to be going from concentration, I'm giving you the big picture here, down to number of moles. Okay? Then we're going to compare the potassium hydroxide, the one substance's moles, to the other substance's moles. So I'm going to go moles to moles, and then moles to solve my question to concentration. This is what I call taking the mole route, okay? Because that's what we can do to compare the amounts. That, remember we said the balanced equation allows us to compare. Now there's a number 1 understood in front of each of those because there isn't a number there. So we understood, like, 1x, you don't write the 1. We've got an understood number there. So that's my big picture. Let's see if we can just start with calculating the number of moles. And I think we're going to need to take a short break. So work with concentration. I'm going to ask you in this break time to maybe challenge yourself and go and work out the number of moles, okay, from this information. Okay? We've just done the equation. Concentration is equal to number of moles over volume. Go and try that for yourself. Thanks so much.
All right. Mindsetters, we're going to take a very short break again, but don't go anywhere because we'll be back with the concentration and the volume and the everything with Tracy, so do stay tuned. Welcome back, Mindsetters. I hope you guys are refreshed and you got yourself some water and some juice to go over the questions that Tracy is going over. I'd just like to remind you that the Career Indaba is coming up from the 20th till the 22nd of June. So make sure you go register, guys. It is for free. So all you need to do is you need to go onto careerindaba.co.za and there you'll register. It is for free, so don't worry, guys, and register. Make sure that you do register in time because it's from the 20th to the 22nd of June and it will be happening at the Sandton Convention Center and we will be there, so I'll see you. Come say hi, tell me what you're doing. If you are confused, guys, about what career path you want to take, if you want to be a doctor, a lawyer, or anything like that, it is a nice place to go because they give you direction and they give you lots of information, so you learn more about yourself as well as know what you want to do. It's not just for grade 12s, it's for grade 10 to 12. So go there, guys, and get a lot of information. I did post all the information that you need on Facebook, so it is there. So with all that said, Tracy, let us begin again.
Thank you so much. Grade 11s, I'm hoping that you will have taken my challenge and gone and solved for the number of moles. We had the concentration, okay, and if I just go up here, we had the concentration is equal to number of moles over volume. We were looking for the number of moles. So concentration multiplied by volume will give me number of moles. The concentration was 1.3. Going back, check it. The volume would be 20 divided by 1,000. If you would have done the conversion already, that's fine as well. So 1.3 multiplied by 20 divided by 1,000. Okay, and we get to our answer 0.026, and coming across here is equal to n, so n is equal to 0.026 moles. Now remember I said you can certainly round off here, and so we could get it to 0.03 moles. Okay, now I said once we've got this mole, we need to then be able to move across and work with the other substance, and it's actually my other reactant, the nitric acid. The reason that we have to have a mole ratio here, we have to have a balanced equation, so I can say, well, 1 mole of potassium hydroxide would react with 1 mole of nitric acid. So my mole ratio is very important. That mole ratio, I'm going to just highlight it here. My mole ratio in this case is 1:1, which means that similarly 0.03 moles would be is to 0.03 moles. And notice this was number of moles of potassium hydroxide. Now we know that that's going to be of the nitric acid, because from the balanced chemical equation it is a 1:1 ratio. So if 0.03 moles of the potassium hydroxide reacts, then surely the same quantity, the same number of moles must have reacted for the nitric acid. And so we need to work out the concentration of the nitric acid. So I've now got to the moles. I now need to work out my concentration. How are we going to do that? Well, concentration is equal to number of moles over the volume. And I have the number of moles. That's a tick. I have the volume. Why? Because they gave it to me in the question. I believe it was 17. There it is. Cubic centimeters. So number of moles, 0.03 divided by 17 over 1,000. Or you've already done your conversion. That's fine. And let's go and put it into the calculator. And it was 0.03 divided by 17 divided by 1,000 in brackets. So it does that first. And I get to 1.76. Let's go across here. 1.76. What would the unit be? This is working in concentration. So moles dot decimeters cubed. Are we happy? I hope so. I hope you worked that out already, and when you came across to it, you're like, yes, I'm getting the same answer as Tracy. Grade 11s, these are incredibly important. I want you to think about taking the mole route, working down to moles, and then comparing the mole ratio. Okay? And then once you've got the mole ratio, you can work to anything else. And I've got a table on this that I'd like to show you. Sorry, it's on the previous page. The fact that you can go from mass to number of moles, or concentration to number of moles, or volume to number of moles, but once you've got those in moles, you can compare the moles using a balanced equation to get the product number of moles, or another reactants, as we've done in this previous question, and then can get back to a mass, or concentration, or a volume. The focus here is to convert to moles, compare the mole ratio, and then work out whatever your answer is. Okay, whatever the question's asking you, a volume or a concentration or a mass. Okay. Now, I've had a question from Mpo. Mpo, I hope you're watching this. Mpo was asking about, I think it was magnesium chloride, am I right?
Yes.
Magnesium chloride. And I happen to have that exact question that you were asking about. So, Mpo, I hope this really helps you. Let's get going through this question. 130 grams of magnesium chloride is dissolved in 300 milliliters of water. Okay, so the 130 grams I'm already listing as my mass, 130 grams of MgCl2 is dissolved in 300 milliliters of water. Now, a milliliter is the same thing as a cubic centimeter. So I'm writing that volume down as 300 milliliters or 300 centimeters cubed. Okay? Once again, watch out, we need to convert that. Okay? 300 centimeters cubed would be the same as 0.3 decimeters cubed watch out for that. You have to convert. So always nice to just do it in the first step. Question A, calculate the concentration. So once again, I get given a mass. I must take that to number of moles. So we can go moles into concentration. Let's work with it. Immediately, I need to say, hold on, I need to work out a molar mass for this magnesium chloride. Okay. How are we going to do that? We're going to go across to our periodic table. And I'll change color again. Magnesium, there it is, magnesium 24, and chlorine 35.5. Sorry, wrong one. There we are. And we've got magnesium was 24 and chlorine 35.5. But hold on, wait. Look at this little number 2 here. It's telling me I must have 2 of those, because in the magnesium to the chlorine is in a ratio of 2, so we have to have 2 of those. Working it out, we've got 24 plus 2 times 35.5 is equal to 95. So my units, my numbers here, 95 grams per mole. Now let's go across and work out the number of moles. So number of moles is equal to mass over molar mass. I started with 130 grams. That's what my question told me, 130 grams. And 1 mole contains 1 mole has a mass of 95 grams. 95 grams in 1 mole. So back to the calculator, and we have there 130 divided by 95 is equal to 1.36. Let's round that off to 37. 1.37, and this is moles of magnesium chloride. Okay? Now I can go across to a concentration calculation, because I think that was what we were asked. Go back to the question. The question said to you, calculate the concentration of the solution. So we've now got concentration is equal to number of moles divided by the volume. The concentration is what I'm trying to find. The number of moles I just found in an intermediate step, and the volume I had. So 1.37 divided by my volume. Watch out, we had converted to cubic decimeters. So 0.3, and let's work out our final answer. We've got 1.37 divided by 0.3 is equal to, let's just remind ourselves of that number, 4.5, round off to 4.57, 4.57, and my unit, well, this is a concentration. I had moles per decimeter cubed, okay? Because number of moles is obviously in moles, and the volume I had converted to decimeters cubed. I hope that helps, and you're working through that. Let's go to the last part of the question, part B. What mass of magnesium chloride would need to be added, oh, this is interesting, for the concentration to become 6.7 moles per cubic decimeter? It already was 4.57, okay? We're now asking what would need to be added. Well, we kind of go through the same question backwards, in a sense, because what we need to start off with is the concentration, and they wanted it to be 6.7. Check it quickly. 6.7 moles per cubic decimeter. The volume, it hasn't changed, it's still 300 cubic centimeters or 0.3 cubic decimeters. And the number of moles is what I'm going to be trying to find. So here we've got the same equation but being asked in a very different way. Number of moles over volume, concentration multiplied by volume is equal to number of moles. 6.7 multiplied by 0.3 is going to give me number of moles. And let's work this out. 6.7 multiplied by 0.3, 2.01 moles. So N is equal to 2.01 moles of MgCl2. Well, what mass is that? Do you recognize how I'm working this whole question backwards, right? I'm now starting with the concentration that they asked me to get, okay, and working to how many moles is that. I now need to take that number of moles and work out what mass would that be, okay, because I'm trying to work out how much extra I'm going to need to add in, okay. So we now have number of moles is mass over molar mass. Recognize that at the start of this question, I already went through the time of working out the molar mass and found it to be 95 grams per mole. Watch out. I didn't write here that this was MgCl2, and I didn't realize that I was going to need it later on in the question. Okay, but you don't want to have to go and spend all your time going and finding those on the periodic table again and doing all that stuff. You've done it already. Okay, so save time, write down, make sure that you're not going to confuse yourself and be able to use that value. Let's rearrange this. So mass at the top is what I've got, what I need to find is equal to number of moles multiplied by molar mass. Mass is equal to, we had already over here, just higher up, we had the number of moles that I want, so 2.01 multiplied by the molar mass, which was 95, okay, grams per mole. So let's go and work those out. 2.01 multiplied by 95, 190.95. Okay, so is equal to 190.95, and this is working in mass, which is in grams. Have we answered the question? Well, not yet, because what we were asked in the question is how much more do we need to add? Okay, well, we need to find out how much we had at the start. Right at the start, they told us 130 grams was what we had dissolved in this water. So we now need how much more? Well, the last part of this question, 190.95 grams minus the original 130 grams, and that's going to be equal to, I can pretty much see it, but I'll show you anyway, 190.95 minus 130, 60.95, 60.95 grams need to be added. So grade 11s, what you need to do here is make sure that when you answer these types of questions, you really think through what is being asked. The best route to take is to convert whatever you get given, to convert that into number of moles. So if it's a mass, number of moles over is mass over molar mass. If it's a volume of gas, okay, then it would be the volume of the sample divided by the molar volume. If it's a concentration, number of moles over volume will give you the concentration. Convert that to a number of moles, and then you can use the balanced equation to compare and work through the mole route. There might seem to be, you might find shorter routes and different things, but make sure that your understanding is we're comparing number of moles. And that will really help you as you work through all of these types of questions. We'll spend time next week going through some more of the in-depth questions where we look at one to another. Okay, so do stay tuned. But thank you so much for joining me. Grade 11s, I hope you have a wonderful week.
Guys, thank you so much for watching. I'd like to congratulate Natasha Sivanda for winning 2 tickets for After Earth, guys. So congratulations to you. Mindsetters, we will see you next time. Same time, same place. It is a cheers from us.